All right, welcome back. Let's look at section 2.4. We're going to be looking at these things called piecewise defined function. So, what on earth is a piecewise function? Well, it's a function comprised of pieces of other functions. So there's usually more than like one type of function that can happen. I really like these piecewise functions just because to me they're kind of interesting to graph because you're looking at multiple types of functions kind of at the same time. All right, so before we get into those, let's look at some parent functions first just to kind of review. And we're going to be kind of combining pieces of these functions together to create a piecewise function. Okay, so the first one, y equals x, well, that's just a line. That goes straight through the origin, right at a 45-degree angle. All right, not bad. Okay, number two, y equals x squared, that's just your basic parabola opening up with its vertex right on the origin. Number three, y equals x to the third. If I was in class and I'd say, hey, does anybody know what this looks like? Hopefully everyone would raise their hand and say, yes, that's the one that slides. And you'd be right. That's the one that slides right through the origin. Kind of botched that, but oh well. Kind of missed the origin. Anytime you miss your point, just draw a bigger dot. All right, now the radical graph, or the square root graph. This one starts on the origin, and then its graph arcs up into the right. It doesn't go totally horizontal. It still keeps climbing and climbing, but it does slow down as x gets larger and larger. Okay, 5, absolute value of x. That is the v right on the origin. Ever wondered why it was like that? Well, it kind of goes off of this graph right here. Because what does absolute value do? Usually makes anything positive. So it's taking this graph and it's taking any negative y and it flips it over and makes them positive. So this little section just got flipped up into quadrant 2. And you can use that little process I just described for any type of function that would be inside absolute value. But that's for another section. Okay, y equals 1 over x. This is the one that has two separate pieces, a curve in quadrant 1 and a curve in quadrant 3. And it has a vertical asymptote at 0 and a horizontal asymptote at 0. So those are your 6 basic parent functions. So example 1, when we're graphing these piecewise functions, we're taking pieces of these things and kind of combining it into one graph. All right, so example A, f of x equals 2x if x is less than or equal to 2, and 1 if it's 2 or bigger. So let's do this first one first. So 2x, that's just a line. It still goes through the origin, but it's just steeper. And I only want that part of the line when x is less than or equal to 2. So here's 2. So less than or equal to 2 means it's everything off to the left. So when I draw the whole, if I drew the whole line, I'm not going to keep it. I can only keep the part of the line that's on x equals 2 and to the left of it. So that would be like, whoops, dang it, missed the origin. So make a bigger dot. So it'd be that part of the line. Now you have to decide on this endpoint here if it's going to be an open circle or closed. And since it has the equal bar, that means you can actually include it, so it gets a closed circle. Okay, now the y value that this occurs, when x is 2, if I plug it in for x, it comes out as a 4. All right, so that's the first piece. The second piece is when it's 1. Well, 1 is just a horizontal line, just like that. But I can only keep it when x is greater than 2, so everything to the right. So the whole thing would go across this way, but I can only start it or keep it when x is 2, and then it would go off to the right. When you draw these piecewise functions, they're never going to overlap each other. Like I couldn't keep any of this because I already have stuff on the, I already have this section, so I'm not going to have like pieces kind of overlapping each other. And I drew an open circle because there's no equal bar. All right, let's move on to part B. So 1 plus x, that's just a line. It's not going through the origin, it's just up by 1. But I can only keep it when x is less than 0, so anything to the left of 0. So the whole thing would be going like that. But at the 0, I can only keep stuff off to the left of it. And that's happening at y equals 1. Oh, I forgot that over here. Now this x-intercept is at -1. Okay, the second piece is your x squared, that parabola right here. But it's only when x is greater than or equal to 0. So anything to the right of the 0 is what I'm actually going to graph. So to the right of 0 is like that. So just draw that piece or that section. And it has the equal bar, so I get a point. Or a closed dot. It goes off like that. So that's kind of like why I like the piecewise functions, is because they're just interesting to look at. Like these are too, but these things are kind of cool. And piecewise functions, like you can do a lot with them. Like calculus, they can be used a lot to help show why something doesn't work. So they are pretty important. Okay, so let's move on. 1 over x and root x. So 1 over x, that was this thing right here, but I can only keep it for when x is 1. So anything to the left of 1 is what I actually get to draw. So this section down here for sure. And then this section here, I'm going to stop it when I get to x equals 1, which we'll say is right about there. Which happens at y equals 1. Now the square root of x, that's what arcs, or it starts at 0, 0, and then it arcs over. So it would start at 0, 0, and it would arc over, but I can only start it when x is 1. So it's still going to have that arcing shape, but I can only keep the part of the curve when x is 1. So it's like I'm only going to draw that piece. So I'm going to put this piece down here. Well, when x is 1, if I plug that in for this x, I get y equals 1. So the radical is going to start where the rational function kind of stopped and left off. So they do connect together. And if an open circle and a closed circle connect together, the closed circle wins and it's closed. It'll fill in the open circle. All right, and then the last one, x squared if x is not equal to 0. So that means I'm removing this point. When x is 0, I'm going to take it out. So I can't actually hit the origin with the parabola. I left out that single x value. But it's like I moved it. So when x does equal 0, I get 5. 5 is up there, so that's where I'm going to put that point. All right, so that's how you draw the piecewise function. So I'll stop there and continue the next one.